Okay, why don't we go ahead and get started? So let me start my timer. Thank you. Amit and I have 3 goals in this talk. Our primary goal is to help you understand the vCenter architecture. And we hope that by going through a deep dive of what vCenter looks like inside, it'll help guide the deployment decisions that you have to make. And as a side benefit to all of this, we also are going to look broader than vCenter and think about our suite, and then help you understand how deploying various elements of the suite may impact how vCenter performs. So my name is Ravi Soundarajan. I'm a principal engineer in the performance group focusing on vCenter performance, and I've been at VMware for a little under 11 years.
And I'm Amit Jani. I'm a product manager on the Suite BU, focused on web client and UIs.
Thanks. So here's what we're going to do. We're going to do a deep dive into vCenter, and we're going to spend a significant amount of time on the web client as well. We're going to talk about performance considerations. We're then going to talk, now that you know how vCenter works and how the web client works, we'll talk about different deployment strategies that you might use. We'll then look again more broadly and say, well, if you're deploying a suite, you're going to be deploying a bunch of different products. What do they do with respect to vCenter? And then finally, we'll have some forward-looking stuff at the very end. So for the most part, I guess many of you, at least in the beginning when I joined VMware, well, frankly, before there was vCenter, this is what you think of when you think of vCenter. You think that you have these clients, whether they're C#, API, or whatever. They're talking to some service called VPXD, which has a database at its back end. And collectively, where this VPXD service was housed was called the vCenter server. So that's kind of the idealized view of the world. And we all know, I guess, that reality is quite a bit different. And I don't want to scare you with this chart. It's a bit of an eyesore, but over the next 20 or so minutes, I'm going to try to demystify this particular picture so you'll understand what goes in it, and that will help you in deploying things for best performance. Okay? And the way we're going to walk through this is we're going to try to walk through the product as if you're deploying it, and then explain what actually happens when you deploy the product. So now let's go ahead and start with our deep dive. And like I said, we're going to march through it as if we were installing the product. So let's go ahead and start with SSO. You've all seen this screen for vCenter 5.5. Now, in very, very simple terms, what is SSO? SSO is this thing that if you register it, apparently I just got a new watch and need to shut it off. SSO is this thing where when you register with it, I as a user can log in and see everything that's registered to it. That's a very dumbed down explanation. Now I'm going to let Amit talk about the value of this.
Thanks, Ravi. So whenever I talk to customers, I frequently hear one main question: why did you add SSO? Everything worked in 5.0 just fine, right? And so I'm going to walk through the 4 key use cases that we thought through, right? Always welcome commentary, so please come find me at the end. I'd love to hear what you have to say, right? But one of the first use cases that we wanted to really address here was, I have vCenters all over the world. I don't want to link them. I don't want to artificially have to tie these things together, but I want to see them in a single pane of glass, right? SSO was actually meant to solve that exact problem. And we'll talk about more of this and later. We have quite a few slides on linked mode. The second one is I have more than one identity source. I don't want to have to, I need to get users and groups from different places. And that's actually the picture that you see here. What's not shown here is, but it's a very common use case, as most of you know. Before SSO, if somebody had permission on the host, they had permission on the VC running on that host. And for most of our customers, or for many of our customers, that was considered a big no-no, right? So now you can now start to create these ideas of security policies to say, there's a host administrator, there's a vCenter administrator, and then the twain shall never meet, right? And that's kind of the direction we're pushing for. And we're in very early stages of this at VMware, but you've heard a lot about Suite, and you're going to see a lot of this going forward. That is not a promise of any feature going forward, so VMware legal can't get in trouble with them. But the key is all of our solutions internally are going to start to adopt SSO, and what you're going to find is one login, and you're into all of your VMware products over time. And that's exactly the direction we're trying to push, and SSO gets us there. Then after you install SSO, the next thing that you install is the web client. I will just say we'll talk about this a lot later, but one of the key values of what you get with, well, first of all, what you install at web client, don't forget we're talking about web tier architecture now. So you're now introducing this idea of 3-tier architecture. So the web client, in essence, is really an application server that gets installed. Right? And then, of course, you just take your browser, hopefully browser, and point it towards the app server, authenticates who you are, and now you have access to your ecosystem, right, or your environment. You see everything that you're supposed to have permission to see now shows up here. So in this example, I have access to 3 VCs. They're not linked, but now I see them in a single pane of glass. That is what the web client gets you, right? We were going to spend a lot of cycles on this, and I know some of you may or may not agree, but the web client was really built around 2 or 3 key use cases. A, we talked about single pane of glass. We'll continue to talk about that. We'll also say that any solution should be able to show up inside of your web client as well. And Ravi has some slides on this going forward. And of course, this is a performance session. We'll talk about issues going forward.
Okay. So thanks, Amit. So as you've seen, you've installed SSO, which is a combination of some C, C++, and Java services inside of this container. You've then installed the web client service, which is a Java service running inside this vCenter server. Now it's time to install the inventory service. Now the first question is, what is the inventory service? So the inventory service, when you install that, you're installing another Java service. Okay, and the purpose of this Java service, this inventory service, is to essentially act as a cache of inventory information. And that's why it's called an inventory service. That's all it is. Essentially, the idea is that instead of having every request for inventory information go to the core VPXD service, let's offload it so that VPXD can do other things. And so this inventory service acts as a cache, and when you go to the web client and you're asking for information, ultimately it goes to your web client server, which then grabs a bunch of data from this inventory service. Okay, that's the purpose of the inventory service. And there are several advantages of having something like this. One of the advantages, as I've said, is that when you make requests from your UI, you don't end up going to the VPXD service to get that information. You go somewhere else, and so you're offloading some of the load from this VPXD process. So that's one benefit of an inventory service. Another benefit is that the way we've architected this, from a partner perspective, partners have commented on how easy it is to integrate with vCenter. In other words, all you have to do is put a little bit of information in this inventory service, and it automatically shows up in your UI. As I depict here, I have vCops installed. vCops puts a little bit of information in the inventory service, and it automatically shows up. They don't put stuff inside of VPXD, they put it separately. Okay, so that's kind of the good news of what an inventory service adds to your life. There are a couple of cons, and I want to be very forthright. I'm an engineer, so I kind of have to tell the truth. So one problem with an inventory service is that by making you install this explicitly, we're exposing our internal architecture to you. And we are working very hard to get rid of sort of exposing these sorts of things to you, because frankly, you should not have to worry about what the memory and I/O requirements are for something like this. So I'll just be forthright and say we're working on this, but that's one disadvantage, I think. And then, you know, like I said, it's basically acting as a cache of inventory information. In doing so, it's basically an embedded database that has memory and I/O requirements of its own, separate from the core VPXD service. So you have to be aware of those requirements for best performance, and we'll talk about that in a little bit. Okay, so at this point, you've installed the SSO service, collection of Java and C++ processes, and C. You've installed the web client service, which is again part of our middle tier architecture, and you've installed the inventory service, which is a cache of vCenter data. Now you're ready to actually install the VPXD process itself. Now, when you install the vCenter service itself, you actually get a number of things along with just core VPXD. So let's go over that. It's basically what's in this diagram right here. So we all know, I guess presumably many of you in the room know what the VPXD service does. It's basically the core business logic of our product. When you perform a task, it's responsible for communicating with your hypervisors, keeping track of task state, and persisting it to the database. In addition, when a VM is powered on or when some configuration change occurs, this VPXD process tracks that and puts that information in the database. In addition, when hosts or VMs generate statistics, historical data, events, and tasks, those get shunted into the database through this VPXD service. Okay, so this is the core business logic of our product. Now, as you can tell, the CPU and memory requirements of this particular piece is important, and we've given talks on this in years past where you've seen this. We'll integrate this all at the very end. So that's VPXD. That's part one of what gets installed when you're installing the inventory service. There's more. So another thing that gets installed is what we call VC Tomcat. And basically, this is a container which houses a number of different Java processes. And one of the things that it contains is something called a health service. The idea behind this health service is that you go to various hosts and you get fan speeds, you get temperatures, motherboard information, and this lets you have hardware health that you can then put in alerts and alarms in vCenter. So that's one of the services within this Tomcat container. In addition, we have SRS, or the Stats Reporting Service. If you've gone to our UIs, gone to the Performance tab, you'll notice that there's an overview and an advanced tab. The overview tab, where you see HTML renderings of data, those are all served out of this stats reporting service. That's what it's there for. Okay, it offloads a little bit of that from the VPXD server itself. In addition, it also has the ESX Agent Manager, or EAM. If you've ever deployed something like vShield, you know that it has agent VMs that have to be treated differently from other VMs in your system. They need different policies, and the ESX Agent Manager is responsible for keeping track of those special VMs. So those things are all housed within VC Tomcat. So that's part 2 of what gets installed when you install the vCenter server. Okay, right there. The remaining things that get installed, well, first of all, there's this log browser service. So the log browser service, whenever you go into the client and you want to look at the log files for VPXD or look at the log files for your hosts, etc., a lot of those things get brokered through this log browser service. Okay? And then finally, it's called various names, storage policy service or policy-based storage management. But the point is, the final thing that gets installed is a service called policy-based storage management. And if you've ever done things like using vCloud Director to set bronze, silver, or gold tiering for your storage, those sorts of things operate by talking to this service. As a result, this service occasionally has to go to our databases, get some information, and pull it down and organize it. In addition, if you've ever gone to our UIs and looked at the storage views tab, the information collected there is funneled through this service right here. Okay? So at this point, I hope you've gotten a broad sweep of what's actually inside of a vCenter server. Okay? And now that you've done that, let's talk a little bit about resource usage. Obviously, with all of these different services, my hope is that you now understand the value of each of those services, and therefore it helps rationalize why you need more resources for what vCenter is doing. So what I like to do is, if I'm trying to do performance debugging, I just wanted to put this slide up to show that if you've ever tried to figure out what's going on here, maybe it can help a little bit. Here's Task Manager. Here's a Windows vCenter, and you can see a lot of different Java processes. Now you know what all of them do. You have VPXD, it's not Java, but the point is there's your VPXD process. You've also got Java processes for your inventory service. You've got Java processes for this web client application server, and whenever you invoke a remote console, that also invokes a Java process. You've also got your processes for your health and EAM and whatever. And you've also got Java processes for policy-based storage management, etc. So when you pull up Task Manager and you see all these Java processes, don't be alarmed. Now you know what all those things are. And honestly speaking, because of Microsoft security concerns, you can't just randomly rename an executable. So what I usually do when I'm trying to figure out which executable is what is frankly, I go to sysinternals, I install Process Explorer, and I take a look at the mapping between the service and what the executable is named. And on Linux, we can talk about, if you're using the appliance, what you might do in that case. Okay? So now that, actually I'll store it on that while I vamp a little bit. Now that you understand what the various services are doing within vCenter, you understand that each of them have performance requirements, and you understand the value that they're bringing. Now let's go into some performance considerations for deploying it. Okay, as you can imagine, with a number of different services, probably the number one problem that I see, and I've been working on this for a long time, is people don't necessarily understand enough to know how to resource their vCenter VM or host appropriately. And so what I want to emphasize is that given the number of new services, we're a bit more sensitive to how much CPU and memory you're giving the VM or the host that's containing all of these different services. And you might have to tune some of the, I've mentioned a number of different Java services, you might have to tune those heap sizes for your use case, because for as many people as there are in this room, that's how many vCenter configurations there could be. And I want to point out that in our documentation, when you look at the minimum system configurations, first of all, I should add that your mileage may vary. You should treat these as minimum, because honestly, we can't pick one number that's going to work for everybody. But at the same time, in some cases, you might actually be better off with less than this. I'll give you some insight in a minute, but this is from our official documentation. The point is, when you look at these numbers, think of these as guidelines for what your minima should be, and use that. The next thing I wanted to point out, it's very important. I spent a bit of time talking about the inventory service for a reason. It's basically an embedded database that if you choose to deploy it on your vCenter server, it co-resides with your VPXD process. Now, in the past, when you've installed vCenter server, you might have just put it on a machine that had some fairly pedestrian disk subsystem. Now that we've got this inventory service, and it's been there since 5.1 and more so in 5.5, This is an embedded database that actually has reasonably high memory and I/O requirements. You're going to want to put this on a system that has a good disk subsystem. So it's the I/O behavior is peakish. It can be 1 to 2K IOPS at times. Okay, and so if you have the option, please deploy that on a separate partition from, say, your vCenter server. Okay, please, if you have the option, deploy it on SSDs if SSDs are available. Okay, but the point is, please plan for the I/O that this generates. Okay, that's very important. Okay, now I want to talk a little bit about heaps. On this chart, what you see is the heap sizes for the small, medium, and large configurations. When you walk through the installer and it says small, medium, or large, these are the heap sizes for 4 different sets of services. The inventory service, the web client. I've called it SPS storage, but that's also the same as SPBM, same name, I'm sorry. And the last one is Tomcat. Now you know what all of them do, and let's focus on the heap size to your left, okay, the small configuration. I want to point something out here. Going by the documentation and by the standard default for a small, when you add up all of the heap sizes, and in 5.5U2, we noticed based on performance considerations that we had to increase the heap size of the web client application server. In fact, that's probably one of the things that's one of the bigger performance improvements for the web client. But okay, so now in 5.5U2, you're deploying this application server and it needs 2 gig instead of 1. Now, if you add up the different heap sizes for the various services, that small configuration, you're going to get to something that's about 6.5 gig. I haven't added in VPXD. Let's say that's 200 meg. I haven't added in the database. You're probably deploying that separately. But the point is, you're looking at about a 7 gig machine. So if you're used to deploying this in the past on something that's maybe 2 vCPU and 4 gig, you might be encountering performance considerations due to these number of heaps. And heaps are funny because if you give something a heap, it probably will use all of it until it absolutely has to give it up. And so in certain cases, you want to reduce the heap to let services coexist together, and you won't see any performance concerns. In other cases, you're actually better off increasing the heap because you have such a large inventory and something scales with the size of the inventory and needs that heap. So this is the kind of thing that, frankly, we should just talk afterward offline, and I can tell you about ways you can monitor this to find out what the issues are. But I want to point out one very, very, very important thing. When you resize the vCenter server, suppose you decide, you know what, I'm looking at Task Manager, I'm looking at top, I think I need more memory, I think the heap is at its max and it's slow. If you just add more memory to the vCenter server itself, that does not change the heap size. You must manually change the heap size for these services, okay? And if you need information on how to do that, come and talk to me, and there are articles that describe how to do this. Really, really important. We have people that'll throw 128 gig on their vCenter server and wonder why they're getting poor performance, and it's because they're not expanding their heaps to take up the additional memory that they've given it. Okay? And that's what my last bullet point is. The heaps are not auto-sized. Very important. Okay. I've talked about the core vCenter server, and I sort of purposely ignored the database until now. I've given this talk at other VMworlds. If you want more detail, you can refer to them, and I put a note at the bottom. But let's go through this briefly. So vCenter talks to the database for a variety of reasons. I've already mentioned that when you persist statistics, they funnel through vCenter and go to the database. I've also noted that when configurations change on a VM or on a host, those funnel through vCenter and go to the database. I've also said that certain UI queries, they don't necessarily go to the application server, they will go to the VPXD service itself. And for example, if you want historical stats, those will go to vCenter first and then get serviced from the database. Okay? And in addition, I've said that we have this inventory service. It's a cache of information from vCenter. vCenter writes to our relational database to source some information so that the inventory service knows what to cache next. So having an inventory service, it's not just an embedded database on its own, but it exerts rights on the core relational database as well. Okay? So that's vCenter talking to the database. And the database, as you've probably noticed if you've ever profiled your database, it also does a number of things on its own as well. First of all, statistics roll-ups from past day to past week to past month, etc. Those things are done by essentially cron jobs or stored procedures on the database. If you've ever profiled your database and wondered why you get peaks of I/O every 30 minutes, every 2 hours, or once a day, that's probably why. In addition, it's also used, the database by itself purges statistics when they're beyond their lifetime, for example, beyond a day or week, month, or year. In addition, if you have enabled events to be auto-purged after a certain time interval, It's not enabled by default, but if you go to the client, you can set this to 180 days or anything like that. If you do that, those events get automatically purged after their lifetime is done. I highly recommend that to make sure your database does not grow without bounds. Same thing for tasks. Auto purge isn't enabled, but if you don't have compliance requirements that force you to keep this information around, it's good to get rid of that after some amount of time, and the database will do it. We also have a couple of tables that are used for computing things like what are the top 10 VMs by CPU megahertz used or by memory consumed. And what happens is that your database is doing a bunch of jobs in the background to tables called top N tables. So if you've ever wondered what are these top N tables and why am I seeing I/O, that's why. And the schedule for those is every 10 minutes, every 30 minutes, every 2 hours, every day. So 30 minutes, 2 hours a day, these are magic numbers, 10 minutes a magic number. When you're profiling, look for these when you're trying to figure out where I/O is going. And then finally, like I said, I think I've used 3 different terms for this, which is bad. Storage policy management, SMS, SPS, they're all the same thing. And this has to go to our database every once in a while to get some data so that it can present storage views and help out with gold, silver, bronze type things. Okay? So with respect to the database, probably the single most important consideration besides resourcing it properly is the latency from vCenter to the database. And as you can imagine by the 2 slides I've just gone over, or I guess the 1 slide I've gone over, vCenter talks to the database on almost every single operation. And so having a small latency to the database is really important. Please don't quote this as gospel, but in my informal testing, what I've noticed is that when vCenter and the database are 10 milliseconds apart or more, it exerts a noticeable performance degradation. And so you definitely want them in the same geography if that's an option. And it's, of course, an option to put them on the same server. The database and vCenter can reside on the same server. I can thoroughly understand if some of you don't want to do that because you'd rather have a separate VM that you can independently size, independently change the I/O and stuff like that. But it's really important to note, now that vCenter has an inventory service with an embedded database, and now that we have our relational database, these are 2 things that need sufficient I/O and should be close together. Okay? Next. If you were to profile the database, what you'd notice is that the bulk of the traffic is actually writes. It's not reads, okay? And part of the reason for that is that if you look at the size of the database, there's 2 types of data in the database. There's inventory data, like host and VM data, and there's what we call seat data, stats, events, alarms, and tasks. You can imagine that inventory data is relatively static once you've built up an environment. And when you do certain operations, we cache a lot of it in vCenter, but if it misses, it goes to the database and reads it, okay? Seat data, stats, events, alarms, and tasks, that stuff grows with time, okay? The more tasks you do, the longer that you go along and persist more statistics, that data is going to be growing and growing. And that tends to be about 85% of what's in your database. That's why we're saying please set your auto purging policies, because that's what's going to make your database grow. You should put those on disks, table spaces, or whatever that you can independently grow aside from your inventory stats. And those tables are by far write mostly. This is why if you just kind of add a bunch of memory to your database machine, you're not necessarily going to get better performance, because eventually it has to get destaged and go to the disk and be persisted anyway. So having a nice solid disk subsystem that can handle writes is actually far more important. If you have the option of SSDs, this is a great place to use them, just like it's a great place to use it for the inventory service. Okay? And one other final thing I'll point out is that there are a couple of tables that are highly volatile, and what database admins will often do is maybe they'll have, of course, the ones I've spoken to, of course, your mileage may vary. Some database admins have a policy that they recompute the statistics for these databases maybe once a day or once a month or something like that. And for certain tables, you might have to increase that frequency. For example, the property bulletin table is a table that's used to help our inventory service know what has changed. Okay? And so it gets updated very frequently. And that's the kind of table you want to change how frequently you're updating its statistics. Otherwise, the statistics get stale and the query plans are old and not as performant. In addition, you now know what these top N tables are. You're computing top N VMs by CPU, memory, or whatever. That's also the kind of table where you should be computing the stats fairly frequently. And a lot of these things we're obviously working on for future unspecified releases, stuff like that. Okay? A common question I hear from customers is how many concurrent operations can I actually perform on this guy? Sorry, on this infrastructure. It shouldn't be gender specific. But okay. So, vCenter has a couple of hard limits. You can issue up to 640 concurrent operations to vCenter before it will start queuing them. Okay? vCenter also has a hard limit of 2,000 concurrent sessions. If you have 2,000 sessions and you try to log in another session, it will get denied. And a session is not just me logging in for a UI client, but it's also a remote console session and other kinds of things. Okay, so be mindful of that. So those are the hard limits from the vCenter perspective, but obviously vCenter is attached to hosts. And the host, we have per host and per data store limits to make sure that your host isn't getting so hammered with provisioning requests that it can't actually do what it's supposed to do, namely run VMs. And so a host, and we'll go into this in more detail in the next slide, a host itself can be involved in up to 8 provisioning operations at a time. After that, it'll queue. A data store can perform up to 128 vMotions and up to 8 storage vMotions at a time. So you can see that your back-end infrastructure where your hosts are running those storage subsystems, their capabilities are going to indirectly influence how fast you can do things within vCenter, because vCenter ultimately has to go to the host and do those things. Let's talk a little bit about the per host limits for a second. I do want to say, as a parting shot on this slide, the limits that we have here can be changed by modifying the vCenter config file. If you want information on that, talk to me offline. And one of the reasons customers do this, well, I'll give you a concrete example. I was talking to EMC, and EMC said, wow, we have this really beefy VMAX or whatever, and we think we can do more. What do we do? And I said, well, change this number, and they got double the performance. Okay? Unfortunately, changing the number of operations that a host can do is not officially supported. And so what I'm going to ask of you is, if you find that these limits are unnecessarily restricting you, please come and talk to Amit so we can go back and qualify things for larger numbers of concurrent operations. We're trying to be conservative so not everybody, so that for the people that have really high performance systems, they do great and everybody else does lousy, but we have to sort of find a middle ground somewhere. Okay? So now let's talk a little bit about the per host limit for just a second. If you want to clone a VM from one host to another, let's say host A to host B, what happens, how we enforce this per host limit is that the charge to this source host is 1. You're doing a provisioning operation, it's being charged 1. The destination is also charged 1. Now they're both being charged 1 unit, which means that each host, because any host can be only involved in 8 operations, now each host can only be involved in 7 more operations. Okay? Let's contrast that to if you clone a VM from a host to itself. As you can see, when you clone a VM to the same host, that host is being charged as both the source as well as the destination. So now that host can only be involved in 6 more operations. The reason I put up this slide is that a very common use case that I have seen is when people deploy a VDI infrastructure, what they'll have is they'll have one template and they'll clone that template to all the hosts that need it. You can instantly see based on this slide why that might have a performance issue, because if one host is being served as a source, you're automatically stuck to only 8 concurrent operations. It's going to limit how fast you can roll out those VMs. And so a better idea is to have a number of different templates that are spread across hosts and distribute them that way so that you can get better parallelism and get closer to that 640 limit that vCenter is exerting. Okay? So that's a bit about vCenter concurrency. Now, most of you, I'm sure, are already beyond 5.0, but if you're not, I just want to give one insight as to why it's a good idea to go from 5.0 to later releases. And I'm going to focus specifically on statistics. We had heard a lot of complaints from customers with larger infrastructures that their database was being hammered because of statistics traffic, rollups, inserts, and things, and purges and things like that. And let me give you some insight as to why that was happening. In previous releases, we would have 4 big tables, one for past day, week, month, and year, and therefore when you need to insert a statistic, you insert it into a large table. When you need to roll up statistics from past day to past week, you're going from one big table to another big table. And when you want to purge data, you have to go and sequentially find a bunch of stats that are beyond their age and then get rid of them. And you can imagine the larger the table gets, the slower this process gets. And what we've done in 5.1 and continued in 5.5 is that we let the application partition each of these tables. Now, an insert is going into a small table, much faster. A roll-up is going from a set of very small tables to another small table. And purging is as simple as simply dropping or truncating a partition. And what we've seen is that many customers that formerly had issues with statistics roll-up exerting an influence on their database have been very satisfied with what this has done. And the offshoot of all of this is now your database is more performant in terms of stats. And as a result, if you need to increase the stats level on vCenter for some temporary debugging, we're able to allow you to do that. Now, I wouldn't recommend doing this permanently, okay? And in order to sort of give you some insight as to that, I wanted to show you a little bit of my informal investigation of statistics. I have to just add the caveat, your mileage may vary, but on my setup, what I had noticed is the following. So first of all, the default out of the box is level 1 statistics. These are some per VM and per host statistics. For example, the CPU usage of an entire VM or the CPU usage of an entire host. When you move that to level 2, you're adding more stats and you're adding a bit more granularity to the stats. Now you might be getting per vCPU numbers, not just per VM numbers. And the offshoot of this is that you're basically quadrupling, in some cases, the number of stats that are going to your database. So even though the back end is more efficient, you really don't want to put yourself in a position where you're constantly putting this load on the database if you can avoid it. When you move to level 3, it gets even bigger because now you have per instance statistics. For example, statistics on a per data store basis. And it's not just per data store, but per host data store combination. So that by itself is the largest jump. That'll increase the number of stats by 6 times or more. So this is one reason we sort of ask you, please don't go to level 3 if you can avoid it, because even though it might work for good temporary debugging scenarios, in the long term, unless you have a very strong disk subsystem, it might cause some performance issues in the database. Level 4 is a little bit more, it adds a few rollup types. It's not generally as big a leap as it is from going from level 2 to level 3. So what I'm recommending is that in our UI, we have a stats calculator. When you say what stats level you're at, it'll tell you how big your database might get. It's a guess. There's a lot of guesswork there, but it's at least a guideline. If you're going to use higher stats levels, like I said, use it for temporary debugging. Don't use it permanently. But if you do find that there is some stat that you really need that is not at our default stats level, please come talk to us so we can see if there's some way we can move the stats level. There is an API for that, but changing it without consulting with us may result in some performance issues. It's good to check with us. Finally, it's important to note that if you need much more sophisticated and advanced statistics capabilities, it might be an idea to go and look at vCops and see if that's what's really going to help you instead. Okay, I included this slide because I get a lot of questions about how to use the APIs. So I'm going to give one simple example, which I hope can be broadly applicable. So the thing about Power CLI, and I'll use Power CLI because I know a lot of people use it, what it does is it gets a lot of information, on any given Power CLI call, it gets a lot of information from the vCenter server, brings it to your client, and then before you get the result back, it does all of the filtering on the client side, okay, within the Power CLI runtime. So take this simple example. Suppose I want to get 4 VMs from vCenter. This is a good example. I give it a list, get VM-name and the VMs, it makes one server call, it gets all the information about every VM in the system and then throws it away on the client and presents the 4 VMs that you want. Now let's contrast that to what a poorly written client would do. If you did this instead, you iterate over each of those VMs, you can all understand why this is a bad idea. Every single call you make is going to get information for every VM in the system, bring it back to your Power CLI client, then just give you the one VM you want. Completely wasteful. This is a trivial example, but I've trolled various blogs where people will show information on custom attributes or whatever where they make mistakes like this. So please be mindful of this when you're using our CLIs. Okay? Okay. Now I'm going to let Amit talk about the web client.
Thank you. So frankly, it seemed impossible to have a performance section without talking about the web client. So let me just start simply by saying, let me be frank, right? We've heard the comments. There's no ivory tower syndrome here where someone says you don't recognize how genius we are and you'll learn to love it eventually. So we will get into some of the things that we're focused on, that the web client team is focused on in terms of improvement. Before we do that, I thought it would make sense to talk about where we were, why we made the decisions we've made in terms of architectural. Again, no justification, but we made some architectural decisions. We should walk through what those are. Ravi will talk about some performance best practices around that. And then we can talk briefly, and of course I'm willing to talk more offline about the things that we're working on to improve the experience going forward. So let's start simply, right? There's a newfound love for the C# client that wasn't there before. People are saying, well, I wanted to talk through what exactly the C# client does, right? So historically, the C# client's job has been to connect directly to the VPXD, to the vCenter server to pull data, right? So all the data is collected from VPXD and shown to the user through the web client, the VI client, excuse me. Right? As you use more and more users log on, of course, there's an increased load that happens on this, especially because the C# client follows what we call an aggressive refresh model, right? The data tends to be fairly live. And of course, as you have more clients, you have more load that's put on top of the vCenter server. So it's a very simple process. The vCenter server was meant to do vCenter server stuff, to manage the infrastructure. As the UI would come along, it would add load on top of that anyway. So the vCenter server is spending a lot of its cycle presenting information instead of managing the infrastructure. And so the goal of the web client was to address some of these architectural issues. Right? The first thing we wanted to do is decouple the client request from the vCenter server itself. Right? And Ravi talks a lot about inventory service. But the idea was to say, let's not add this extra load onto vCenter server. Let's kind of decouple these so that scale becomes more possible here. Right? And I was seeing an older performance chart from, I think, 5.1 or 5.5U1 that says for the equivalent of 50 VI client sessions, C# client sessions, you're getting about the same load for 150 web client sessions. So in that one way, we did succeed. The idea, of course, is that you have more and more users that are there, right? The other key goal of the web client was really around extensibility. When VMware was there 7 or 8 years ago and the C# client was the only client, we were the center of the virtualization world. We'd like to think we still are, but frankly, you're telling us we're not. There are lots of solutions and plugins that need to be there. And so we want to make sure that we were there that was part of the core of the web client design, right? That everybody should look as peer to us as we are. The other one is, and you've heard a lot about it this week, we're really getting into this idea of managing both on-prem and off-prem use cases. And so we wanted you to be able to do that from a single pane of glass. I won't use single pane of glass a dozen times, but it is a big theme of what we're trying to do. And the web client with the architecture helped get us there, right? And lastly, we wanted to get into a platform independence. Over the last 5 or 6 years, the number of Macs in the administrative environment has quadrupled. I think some of the data I've seen shows. The other one is, of course, Linux desktops. Surprise, surprise, Linux desktops are really taking off. And so we wanted a client that worked natively in all of these different environments. And I told you I wouldn't use single pane of glass again. But think of the use case simply as when I see a VM in my UI, I want to right-click on it and see all of the options that are available to me on that VM. And that is really at the heart of what the web client was meant to solve. Right? So breaking that down into what it means with implementation, we talked about this. It's a 3-tier architecture, right? So you have the app server. The browser connects to an app server, which, of course, pulls data from the inventory service. So the application server is at the heart of the web client. Right? It retrieves this data from the inventory service, and Ravi talked a lot about this, right? So of course, when anybody, whether it's us or a third party, server vendor, storage vendor, or anybody, can put data into the inventory service, it automatically shows up in the UI, right? So somebody can add data to a host, whether they're a third party or not, and say, it's this firmware version, it's this is your warranty information. That shows up automatically inside of the web client. Right? To further offset some of the load that we were putting on this, we decided we were going to follow a reduced refresh model to say that things were as they were and we'll update them over time. And then, of course, we started this work about 5 years ago. At that time, HTML5 was still in extreme infancy, believe it or not. I don't know if you remember. But so we were looking to copy this rich internet experience that you had. You had a rich admin experience with your C# client, and we wanted you to be able to have that same administrative experience in the web browser, even if it's a web browser. And so Flex really offered it to us at that point. Right? So that's where we are. That's where we are with the implementation. We've gotten a lot of feedback. This is a very, very small subset of the feedback that we've gotten. But these are some of the key areas that we're looking to focus on going forward in the web client team. So the first one, of course, is we talked about Flex. Flex as a platform choice. Right? There are lots of issues with Flex. And we're working with that team to address a lot of those concerns. The second one was performance. And just off the top of my head, some of the big 4 or 5 that I hear are login times, refresh, menu refresh. Performance charts with more than one metric in it often slows down. These are definitely very well understood now, and we're looking to address a lot of those things. There's also, in addition to making a lot of performance changes, that one of the things we did was we tried to outsmart ourselves possibly here and try to do what we call a smart port. We said some functions you don't use very often, we're going to try to hide those away so that it doesn't get in your way. Some things are more common, we want to put those more front and center. And so what resulted was this change in a navigational model, right? And the feedback has been very clear on that as well.
Actually, if the performance were blazing fast, how many of you would still have issues with the navigation? Okay, this is good information.
Yeah.
You should definitely talk to me afterward. Thanks. Sorry, Mika.
Thank you, Ravi.
I'm the performance guy, so, you know. No.
And then, of course, we talked about inventory service, so we don't need to talk about that.
So since I'm the performance guy, let me take this slide.
Sure.
that was scripted. That wasn't improv. Anyway, by the way, a lot of you are taking pictures of these slides. I want to point out that first of all, I think you're going to get them afterwards. Secondly, if you have one photo left in your camera, wait till I'm done and take a picture of this slide. Okay, it's kind of, I think it'll be helpful. So I'm not going to lie and say that we're going to make this web client blazingly fast by the things I'm telling you to do here, but I am going to say that informally these are things that have helped our web client experience in the 5.5 time frame. Okay. The first thing that we've observed is that Chrome and Internet Explorer, whether version 9 or version 11, both seem to perform better for us than Firefox. Okay? Now, this might sound counterintuitive, and I'm just deeply very, very sorry about this as a performance person, but your browser machine, given that we're running Flex, needs to be fairly beefy to effectively run the web client. If you're deploying it on some VDI setup where you give everybody 1 vCPU and 2 gigabytes, it's really not going to perform very well. In my own impersonal, informal testing, I tend to give 2 vCPUs and 4 gigabytes to the machines that are running the browser. And again, that's just because of memory requirements of Flex and other things. Okay? It may sound kind of obvious, but faster CPUs definitely help. And I'm talking about faster CPUs not just on the machine running your browser, but also on the machine running your vCenter server and your application server. The reason that's not obvious necessarily is that in the past, we had some synchronization bottlenecks that couldn't really take advantage of faster CPUs, but we've done a huge amount of work in relieving those. As a result, we can take advantage of faster CPUs on the vCenter side, and you can clearly take advantage of them on the browser side. Another thing that's kind of important is I've talked about the application server and the inventory service, and it's a fairly high traffic link between them, and so it's really important for them to be in the same geography. It's better not to put your application server somewhere separated by a WAN from your inventory service. That's not going to give you the best performance. Here's an interesting one. So if you're using a browser over a WAN to your servers somewhere else, you're going to get a WAN-like experience. What I would recommend and what we've seen is the concept, basically kind of using a jump box. In other words, RDP into the geography where your vCenter server and your application server exists, and use a browser in that geography, because that more or less converts a WAN-like experience to a LAN-like experience. And this is proven, this has a fairly substantial performance implication because we do exchange quite a bit of data between the browser and the backend services. So putting them in the same geography is fairly important. And finally, I've talked about heap size. Actually, I talk about heap size for both the application server as well as the inventory service. Like I said, if you just resize either your browser, if you resize your vCenter server machine, you don't automatically get heap size increases. You have to do that manually. But please make sure that not just your application server, but also your inventory service are sufficiently resourced. And we can talk a bit, perhaps in question and answer or afterward, about how you might determine that you need to increase those. Okay? So these are some ways we hope can improve it, and we're obviously working on this in the future. And to let somebody talk about the future.
So let me just, before I go forward here, Ravi gave a lot of best practices around some of this. I want to assure you that the engineering team is looking at optimizing the queries and all these. There's a lot of performance work going on behind the scenes as well around query optimization and caching and all that. So let me show you, would people like to see some of the changes that we're looking at making? Okay. So for legal reasons, I cannot say when these will come out, but I assure you nobody is more motivated in this world to get these changes in your hands than I am. So let me just start talking about some of these things, right? So the first one is, we've heard a lot of feedback that said, hey, that you've moved tasks to the right-hand side. They're very confusing. I can't see my full menus. So one of the things you're going to see, hopefully soon, very soon, will be that the tasks will get pushed back to where you're used to seeing them with the C# client, right at the bottom, right? So you'll get the list where it was there. The other one is right-click. Two things, it has to be faster, right? And the second one is stop burying everything into submenus. You're going to see that, I can't say it legally, but you will see that very soon when you'll have a much flatter list of things on the menu side, right? So you can right-click on it and see all of your options right there.
And they're aligned with how they were in the C# client.
Yeah, exactly. Right, and the other, these are... There are many, many changes that are coming. These are the three big ones that we've heard frequently. And we have the vSphere web client guys here as well. So if you want to come up and see us afterwards, I know Matt and everybody will come up and be eager to take that feedback. And then lastly, we heard the web client is awesome. No, nobody says that. But what they do say is, I get lost in where I'm clicking around, right? And so the idea was to create these shortcut keys so you can jump from one view to another very easily to stop from being lost in all of this, right? And so we can talk about future, I think, towards the end, but
Yeah.
let me get back to you for deployment.
And despite our lame attempts at humor, we actually take this really, really seriously. And I'm personally very sorry that you're not getting the experience you want.
Yeah.
And I'm just working really hard to make that not be the case in the future. So now that you know everything about how vCenter works, how the web client works, etc., let's talk about how you might deploy vCenter and things like that. So the caveat I'm going to add is that this talk is really about empowering you to make the decision about whether you want one vCenter or whether you need multiple vCenters. Okay, there's a whole separate discussion about whether, given that you have to have SSO, do you need linked mode, etc. And for that, I'm going to try to give you some guidelines. Okay? So, when you're talking about deploying a single vCenter, clearly one simple model that will work is to put everything within one VM. And the nice thing about this is that this gives low latency between all of the different services, and now that you know what they are, you know how important that is. However, the drawback clearly is that you need a fully resourced VM, CPU, memory, and I/O. Okay, and we understand that this is slightly deviant from previous releases, but we're trying hard to sort of enforce this as a good model for deploying things and tuning performance for something like this. Now, we also recognize that the vast majority of you use an external database, and that's also a completely valid and reasonable way of deploying vCenter. And of course, you still get low latency between all your services and between all of your dependent services. If you've done the best practice of not putting the database in a separate geo, you also get reasonably low latency to the database. Okay, so that's pretty important. And like I said, this aligns well with how most people deploy vCenter today. So 2 good ways to deploy vCenter listed on this page. Now, in past versions of this talk, one big question we had was, well, when I'm deploying it in remote geographies, is it okay to have vCenter in one geography and my ESX hosts in other geographies? Perfectly valid. Okay, nothing wrong with that. I should point out there's a nice little white paper. Although it's a bit old, the information is still timely and relevant, and it talks about some of the operational latency issues that may occur if you choose to deploy this. To summarize the white paper in one sentence, I would say that vCenter's performance is more sensitive to latency of the link than it is to the throughput of the link. In other words, if you made the link twice as slow, that would be much worse than reducing the bandwidth available on that link. And the white paper gives a number of good examples for that, okay? So, I will say that for the ESX hosts themselves, for your hypervisors, of course, within a geography, you still want them to have high bandwidth so you can have good failover and vMotion, etc. Okay, so that was a single vCenter. Now you understand when you might deploy that. People deploy multiple vCenters for a lot of reasons, and it's not just because of scale. To talk about scale for a minute, there are some customers that say, you know, I issue a lot of automated operations to my vCenter, a lot of power on, clone, reconfigure, and whatnot. And so for my use case, maybe after about 50 operations a minute, I like to have a separate vCenter, so I'm not sending everything to one vCenter. I like to have better parallelism that way. First of all, now that you understand a little bit more about how concurrency works and how to deploy for concurrency, you might not have to do this. Secondly, I should point out that we tested 10 times this load and handled it just fine. So your mileage may vary as to when you'd want to split this up, but I'm giving you this that some customers use this as a best practice. Another reason that you might use more vCenters is for increased number of VMs and hosts. We publish limits of 1,000 hosts and 10,000 VMs. Honestly, it's heavily sensitive to your configuration of hosts and VMs. And for some customers, what they seem to do is they say to me, they say, I have a sweet spot. After I'm 200 hosts and 2,000 VMs, I go ahead and spin up another vCenter. I don't like to have all my eggs in one basket, etc. So I just wanted to share that with you because it's something that some of our big customers do. Now, as I've said, beyond these scale reasons, there are other reasons you might want to deploy additional vCenters.
Sure. I'll just be brief here. So one of the things we hear often there are political, and I'm using air quotes here, reasons for wanting to separate multiple VCs, right? The first one tend to be different business units run different workloads, so we want to put them into separate VCs. The other one tends to be security, right? I have highly secure PCI workloads that need to be behind triple DMZ versus non. So we put them into different VCs. And then the most common one that I frequently hear is, which I do with server workloads versus desktop workloads. And the big thing that customers tend to do is separate them into different vCenters as well. So those tend to be 2 or 3 big reasons for separate vCenter servers. The other ones are geography. Ravi talked about remote office, branch office, this idea of running ESX agents, or ESX hosts in Asia, now they're having a VC over in North America manage it or not having a VC at all. There's been a shift in the last year or two where I'm seeing customers are actually just putting a VC, in this particular use case, in Asia to manage those, right? So you're seeing a lot of geography that goes on as a reason for having multiple vCenter servers as well.
Thanks. So what it comes down to is you figure out whether you want one or more vCenters, and given you have to deploy SSO, you then figure out how do I do SSO and linked mode, et cetera. So let's talk very, very briefly about that, okay? What does SSO give you by itself? By itself, SSO can enable you to have a single pane of glass in your UI. Sorry for using the term again, but you can see all your vCenters and solutions in one place. It can allow you to also have a federated search across all of your vCenter instances. Now, it does not require any Windows-specific technology, so it works equally well on your vCenter Linux appliance as on Windows vCenter. However, SSO by itself will not share licenses, roles, and privileges. Okay? If you take and now look at linked mode, as with SSO, it provides you a single pane of glass in the UI, and it provides you UI search across vCenter instances, but it also provides shared roles and privileges as well as shared licensing. However, it's a Windows-only technology, so you have to be running the Windows vCenter to get it. And, sorry for someone taking a picture over there. So, now, let's talk a little bit about the performance considerations. A lot of times I get the question, hey, I'm deploying linked mode or SSO, do I have to reprovision my network for cooperating vCenters? And the short answer is, first let's talk about what sorts of implications you might have. When you communicate with different vCenters, I'll just be honest with you, your login experience might be slower. It might be slower because you have to contact vCenters, some of which might be remote, okay? In addition, search might be slower because we have to contact multiple vCenters to generate a search result for you. I should also point out that along the same lines, if you have one slow vCenter, you might end up seeing slower responsiveness during login or during search, okay? And if a vCenter goes down, you might also see slow responsiveness because it's waiting for that vCenter to respond and it won't respond. Having said all of that, to get back to what motivated this particular slide, there's not a lot of data exchanged between vCenters when they're in SSO or linked mode. There's some data that's replicated. The only time you see large bandwidth across these links is when you're doing a federated search and have to go across the link. Other than that, the metadata they exchange is typically quite small, so you don't probably have to reconfigure your network to accommodate that. Okay? Now, personally speaking, in preparing this talk, I realized there was a ton of confusion, and even I got confused about SSO, so I figured I'd pass on some of what I've learned to you. And a lot of it comes from, well, personal experience, and also I would heavily recommend looking for all of Justin King's work. His hashtag is vCenter guy. He gives a lot of good blogs on SSO usage. But to dumb it down, sorry, I don't mean to say dumb it down, but to simplify, the very first, so when you're installing SSO, you're typically given 3 options when installing a vCenter and SSO. Option 1, you always use that for the first vCenter that you deploy. Then the decision point becomes whether you use option 2, which is named high availability, or option 3, which is named multi-site. So let me give you 2 concrete examples here, okay? In a LAN, you deploy your first vCenter and you know you have more vCenters to come inside of that LAN. So what you do is you put SSO externally, and when you add another vCenter, you might want to add another SSO for redundancy or whatever, so you typically put in a load balancer, put your SSOs behind that load balancer. Okay? With this configuration, you keep adding vCenters. You don't have to add an SSO per vCenter. It's 2 will scale fine. But the point is all of these vCenters now, because they're behind, your SSOs are behind a load balancer, you get a single pane of glass. Okay? It's important to note you have to have that load balancer and you have to configure it, but once you configure it, you've got a single pane of glass. You don't have sharing of licenses and roles though. Okay? Number 1. So that's a LAN. Now let's look at a WAN. In a WAN, it'll be slightly different. You're going to deploy your first vCenter, and the bottom line is you deploy option 3, but let's talk about that. You deploy your first vCenter, give it its own SSO instance, okay? Very first, option 1. The next vCenter you deploy, you choose option 3, the multi-site option. You're going across a WAN, you want less data exchanged than you would have wanted in the high availability configuration. The next vCenter that you deploy, you also put in a multi-site configuration, and for best performance, make sure to define your WAN replication partners properly. What does this give you? Very, very important. This configuration does not give you a single pane of glass, okay? It's just a multi-site configuration for SSO concerns. To get a single pane of glass, to get query federation, to get sharing of licenses and roles, to get all of that, you have to use linked mode, okay? So if that's important to you, use linked mode. Now, just because I thought it'd be kind of cool, I made this very same mistake. I thought I'd pass it on to you. What is wrong with the following picture? I deploy my first vCenter, option 1, terrific. Put an external SSO, great. Deploy a second vCenter. Go ahead and use option 2, the high availability option. But I don't put in a load balancer or anything. I just point it at the same SSO node. And I do that consistently for all of my vCenters. What's wrong with this picture? Well, what's right about this picture is I do indeed get a single pane of glass. If I log in, I can see every vCenter. What's wrong with this picture is I've got a single point of failure. If that SSO goes down, you can't contact anybody. Okay? That's usually not a good thing. So that's wrong with this picture. What's wrong with this picture? I go ahead and I start with my vCenter and I give it its own SSO instance. Okay? Then I use option 1, I deploy a second vCenter, give it its own instance, but instead of using multi-site, I use the high availability option. Okay, so option 2. And then I deploy another vCenter and I also use option 2, high availability. Well, I'll tell you what, the good news is that I have a single pane of glass here. Okay, if you configure it this way, use option 2, high availability, you are going to get a single pane of glass. The bad news is you've got another single point of failure here because whatever you designate as the primary node, if that goes down, you don't have access to any vCenter. So don't do this. It's called high availability / load balancer mode because you need to have a load balancer to make sure that you don't have a single point of failure. Okay? So hopefully that's been of value to you as a learning experience to me, and it's something that we're working on. Okay, we've talked frankly ad nauseum about vCenter. Let's take a broader view, and we're almost done. Don't worry. We're going to talk a little bit about the suite. And basically, we know that many of you deploy, I don't know, VCOps, VCAC, whatever. You maybe have a management cluster where those VMs are running, and a separate production cluster where your actual ESX, your sort of workload VMs are running. Totally fine. That's cool. Just a couple of things to be aware of. If you deploy VCOps, VCOps is very I/O intensive, so put it on a different set of spindles from your vCenter server. Very important. In addition, vCOps reads statistics information from vCenter. It's not reading historical data, it's reading data that's serviced by vCenter by going to the hosts. And so you might have to provision a little bit more CPU and memory, et cetera, for vCenter to handle this additional load. Okay? If you're deploying VCAC, very important, VCAC has as its workhorse the VCO orchestrator, which sits within the vCenter server. I didn't talk about it, but it's there. The more workflows that you have, the more potential performance impact you might have. So you have to think about the heap size for that service, and you have to think about the resource requirements of the vCenter server that's running VCO. If you're using a lot of workflows, those might have to be increased. Okay? And then finally, if you're using NSX, the single biggest advice I can give, and we've actually fixed this in our default configuration in 5.5U2, the NSX web client plugin takes an additional a couple hundred megs in the web client application server. So if you were using the default heap, you would see poor performance even if you're not even using NSX and you just installed it. So you have to increase the heap size if you're using it. We've done that by default in 5.5U2. Okay? So now let's let Amit talk about the future.
Yeah. Ravi likes to give me the legally challenging stuff, but I will just say generically, I know a lot of questions will come up about this. These are areas we've heard very consistently and are very focused on. But one of the key ones we always hear are on the Linux appliance, and when does it become peer to what we do with the Windows stuff. I'll just say generically, there's a lot of exciting things that happen when Linux becomes the primary delivery mechanism, and we're looking and focusing on that a lot. The second is web client technology. I mentioned Flex as one of the decisions we made 4 or 5 years ago. We are always evaluating new web technologies, and we're doing that internally. In fact, Yiting is here. She's our mobile PM. She'll be in the back. She can give you an advanced look of some of the things that we're doing with mobile, and you get a sense of where we're going to be thinking about going forward with the full web client also. We hear a lot of questions about cross-VC vMotion. We know that there's a big use case. All I can say is you see as hybrid becomes very important to what we do, we don't want your workload to be restricted to the boundaries of vCenter. We want you to be able to move them anywhere, and so we are looking at that. Ravi went through in good detail the idea between linked mode and SSO, and it seems kind of silly to a lot of our customers that you would have 2 different technology choices to do mostly overlapping use cases. So clearly that's not sustainable, or that's not optimal, and we're going to look at focusing on that. All I'll say at a very high level is we put a lot of investment into SSO. What you see it doing with users and groups, we'd love it to do with everything else in VC and beyond. And then, of course, Ravi can talk about the performance
Yeah, for the
stuff.
performance improvements, I'm going to say we've already talked a bit about the web client. We've talked a bit, well, we haven't talked about this, but there's also a number of charts within the web, within either client that are slow. For example, some performance charts, and we're working aggressively to fix that. In addition, we've dramatically increased, or we're in the process of dramatically increasing the concurrency that vCenter can support. And so stay tuned for whenever that's going to come out. But we've done a lot of work in that area. So just to conclude, it was sort of a running theme throughout this talk that for vCenter to run most effectively, it needs to be sufficiently resourced, and I think you now understand what that involves. When you're deploying things like SSO in linked mode, now you understand SSO, so hopefully it'll help you understand when you're going to need linked mode. When you add more solutions, you now understand what impact some of those solutions have, and you'll understand how to resource your vCenter appropriately. And finally, as we've sort of said time and again, performance is a really big priority for us in upcoming releases, and so please stay tuned. With that, I'll say that there's a lot of other talks. I'm not sure if they're done yet, but if they aren't, these are great talks, some of my friends. And please fill out a survey if you like the talk. I don't like to end on a useless slide like this. I'd rather end on a slide that would actually be helpful. So let me either end on this one or end on the conclusion slide. Take your pick.
Thank
First,
you.
this one or the other one? This one? Okay, you guys win. Or you.
Thank you, everybody.
Thank you very much.